My name is Rahul Ulkar. I'm been working as a senior architect in ULIC Systems. So today we are here at XLR Systems for the placement drive, and I really appreciate the placement services that I mean the team that I actually met. We really got a good service and hospital service actually. They the way they actually welcome is really fantastic, and I love this is actually my one of the best experience that I have ever. And yeah, and about the student quality, today actually we had a interviews with almost like 25 to 30 students, but the candidates are really good. I mean, with respect to knowledge, with respect to communication, I mean, they are much more familiar about the technologies. Most of the interviews we had in Java, and the students are really fantastic. Thank you.
I'm Hariprasad Bugate. So today we have come here on the behalf of Urix Systems, and so we are conducting a drive at XLR. The students here, they are also, we found them very confident. Thank you.
Hello everyone, my name is Mayuri Pimple. I have completed my full stack development course from the XLR EdTech Private Limited. The XLR is doing the fantastic job. The XLR placement team is doing the excellent work, and they are also providing the SDP session that boost our confidence at the next level. I would like to thank the whole training and placement team of the XLR for arranging the drive at the XLR Pune office. Thank you.
Hi everyone, my name is Sunita Joshi. I am from Pune. I have completed my full stack development course from XLR. The training provided by the XLR was very fantastic. The placement was provided are also good. There are the various SDP sessions was conducted at XLR office so that student can enhance their skill and knowledge and crack the interview and boost our knowledge to the next level.
Hello everyone, my name is Omkar Sarve. I have completed full stack developer course from XLR EdTech Private Limited. The training provided by XLR is flawless. They provide good placement support. They doing STP sessions regularly to boost our confidence to the next level. I would like to thank whole XLR team to arrange the campus drive at
My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Yeah. Good evening, guys. Uh, right. Today's agenda is about that machine learning algorithms on the part of recommendation engines as well as time series, which we are going to see in the sessions. We know that recommendation engine is very much popular in nowadays, where we see that every platform is running its own recommendation engine itself. So all these engines are been starting out. Okay, all these engine has been starting out by initiation with the machine learning algorithms, which is in the backend model. So everywhere where you see that all the platforms nowadays are using that recommendation engines, not only one domain I'm not talking about. It's all about all the domains where we see that uh, all the platforms running on that. Let's see that what is that recommendation engines, why do these platforms came into an existence, all that. So I think all of you are able to see the screen, guys. Yeah, need a quick replay from your end. Right. Okay. Right. So, okay. So we're going to start on that scale. Right. Most of you have heard that recommendation systems, okay, basically works on every platform. Like, okay. So what is this recommendation engine? So when we talk about these recommendation engine is, it's a one kind of filtering systems, okay, that seeks to predict by an user interest itself. Okay, what is that? Okay, it's one kind of filtering techniques available that where user is able to predict that based on that information which given out by the user or some other platforms, like the people are coming out from that different things they were looking out for that. So the it may or may not be some accurate results which we are going out to see. Okay, majorly it's used for digital domains such as we see all that recommendation engines working on with that various platforms like Netflix, Amazon, Flipkart, and nowadays you're seeing all that platforms are running with that recommendation engines, like all the OTT platforms where you see that, and all that retail domains, like all the apps which you're running out in the e-commerce sites, or all are now back end running with that recommendation engine. So what advantage we can adopt with these recommendation engines? So what kind of advantages when you see of that? So there are several advantages is that, okay, it can boost up their revenue itself. Okay, basically, it could boost up their revenue. Instead of, suppose you want to buy a phone itself, okay, it will suggest you to recommend you a charger or the case or earphones, all that. So it will suggest you that, and for that suggestions, you are going to buy that product itself. Instead of searching down there in the search button itself, you are going to see all that products being taken down into consideration, and you're going to buy all that products itself. So it's all about dealing with the customers with simplicity itself to generate their revenues itself. So it also makes some conversions simpler, like instead of seeing out that. So how do these recommend? How do these products are being recommended to that? So what are these in the back end? Like how do these products are being recommended to? So various things are in the platforms. Like various things are there into consideration. Like, so I'll tell that what are that things are there for that consideration into that. So what makes this algorithm very much popular in nowadays, that okay, in the recent times this engine has been running out very widely for all the platforms which we are going to see out there. So next, as you can see this image itself, what does this image shows you that it shows that your products being taken down into considerations of where product A is being sold upon that. Suppose your product which A you're been viewing up. Okay, it's one kind of paint system where you can apply your paints on the walls on that. So when you are going to buy that or when you're viewing that products itself, okay, it will show you the other products which the other customers are also being used or the other customers are also being used viewed on that. Customers you who viewed this also being viewed. So the customers which have viewed this product A, also the customers have been viewed this product B, C, D, because all these products which you are going to see, all that product A, B, C, D are being related to each other with the same aspect itself. So that's the reason the product A is being seen out. The same kind of products linked to that other people are also being seen that. Okay. See these kind of filtering tools which we see that. Okay. It's called as and recommendation systems or the recommendation engine itself. So as you can see that when you are using that platform called as Amazon itself, so you're using a platform. Suppose you're going to buy a book called Peter Cropper of the book itself. So that when you're buying that kind of book itself, okay, it will recommend you the same kind of novel journal itself. The other books will be recommended to you. So it's all that depends upon that recommendation engines which is running in the backend. Okay, what is that? Why do it recommends all that itself? So to that, what does when you apply that kind of recommendation engines in the backend itself? What could these advantages getting out by these people itself? Okay, they can increase their order values itself. The worst thing is that they can increase their order value because the people also see that kind of books whether they are much important or not, they're going to buy that kind of books itself because people may feel that this could be some useful for that purpose. So like that these books can be recommended or the products could be recommended or the movies could be recommended to the customers itself. So that's what it happens to that. Suppose you see that you're going to buy a product of Samsung's some mobile itself from X mobiles. So it will also recommend you the cases as well as your tempered glass itself. Okay. So these are one kind of recommendations being taken down. Okay, into consideration itself. There are various recommendation engines which are in the back end over there. So basically, it comes with collaborative, content-based, all that hybrid models. So as you can see that Netflix is one kind of platforms running out over there. Okay, that platforms will show you that. Okay, that platform will show you that the same similar kind of movies which you're watching. And suppose you're watching some movies where you have good rated movies, so it will recommend you the good rated movies on the first time itself or the second time itself. So this is what it shows that it is being that collaborative by the user collaborative filtering systems. Okay, the same user. Suppose the user A is watched out with the movies of the journal. So some journals with the scientific fiction movies. So it's the same similar kind of movies been also been recommended to the product B. Why it happens is that because the product so the user of A and the user of B having the same relationship between each other. Why that relation is then happen is that so that relation is nothing but whether you're watching it with that same location itself or whether your age group has been matching out or whether your the watched movies is very synced to that age group of that same location on that customers. So it is also being recommended to that same group of people, those who have been watching out to that. So it all becomes with the correlation factors on that. So it's been correlated with that similar persons on that. That could be a one kind of recommendation system in the filtering techniques, generally called as one kind of filtering techniques. So like that similar, suppose these two similar persons are reading the same books on that case. So that book which will be recommended to the other people, those who have been reading out all that. So it's all depends upon that movie ratings and the books, all that factors. So let's get back into that practical part of exploring that algorithms itself. So shall I will share my screen. Let's do that. So we are opening a platform called Google Collab with you. New notebook. Right. Okay. Initially, what we do, we import all the libraries related to that. Yeah, you will get the recording session, no issues. So import does as PD. We're connecting to that. So next we are loading the data set itself. Vishal will load the data sets. Okay. The meanwhile time I will load the data set. Like we have a two data set files called as. So in the previously we have loaded only one data set. Now I am going to load the two data set itself files. Data sets is been uploaded. So why two data sets are being uploaded is that we have a, information between the two data sets itself. Right. So we are just importing that all the values on the data set like so the column names are visible to that and we have used the data set called as DEF. Let's run that. I'll show you that what this data set is all about. We have a couple of records on that. I just want to show that df.add. So what is this data set is that? Okay, we have user ID as well as your item ID. We have user ID as well as your item ID and the rating and the timestamp. Means the thing is that now we are going to recommend a movie system. Okay, now we are going to do a movie recommendation systems. Okay, so this is D5. Sorry, D4. So now we are going to see a movie recommendation system. Suppose you're watching a movie itself. For next, what kind of movies should be recommended to you based on the watched movies Suppose you're watching some movies called Liar and Lair, which is a very comedy movie, which is okay. So for that, what is the next movie should we recommend to you? Like suppose you're watching it's any kind of triple R movie itself. Suppose on which kind of movie should be recommended to you. So this engine will work like that. Suppose on the same phenomena when you're going to buy a product itself. So if you're buying that kind of products, what product should be recommended to you? So that's what our intuition now we are going to do is that. So in this data frame where you see that we have user ID. User ID is I am the user. I'm the user and you're the other user. Your friend is other user and their friend is other users. So every user having their own IDs itself. Every user is having their own IDs. So I buy the same product. I buy suppose I'm buying an Apple iPhone of 15 itself 15. So you're also buying the same Apple iPhone of 15 and your friend is also buying the same Apple iPhone of 15. So the item ID remains the same itself, but the user ID is changing in that scale. So if I'm buying that iPhone 15, the product ID is suppose 50. So the product ID will not be changed until and unless you're not buying the product itself. That's it, simple. So for that product or the item which you are taking down, that we are giving the ratings. Okay, every time I will not give the same rating. If the three persons are XYZ are buying the same product, their item ID is 50, but the ratings could be different itself. On what timestamp they are going to buy, this is the timestamp itself. Just ignore that timestamp over there. It's all about the binary digits of formats converted to that ASCII values on that scale. Okay, just ignore all that. Okay. Guys, it is clear what I'm talking about. Any doubts with that? We have a data frame loaded on that with the user ID, item ID, and the product ratings. That's it. So we are now going to see the movie recommendation systems, like which movie should be recommended to the after watching one movie, what are the other movies should be recommended to the person itself. That's what we are going to see here. Guys, are in the path, are in the track which I'm going to tell that you're going to follow me. Just ping me yes if you're following that. Right. Okay, these recommendation systems will be very much useful for your projects to undergo that. Okay, because these recommendation engines are being used in every platform, not one. You're using these in the low cases platforms also. So like all the OTT platforms, you can name any one that has been running with this recommendation engine itself. You can name any one itself. So all are using these recommendation engine platforms itself, where you can develop that kind of recommendation engines for your choice itself also. Next thing is that I am going to load another, what is that? I am going to load the another data, sorry. Okay, another data frame called as movie titles itself. Movie titles is nothing but I want to recommend a movie titles after which movie, what movie to be applied on that scale. Okay. Just I'll run that data frame which I've loaded. I loaded two data frame, guys. This is the movie titles data frame and this is the user data itself. Okay, both have been loaded. Okay, now I will show you what is this data frame is all about. Right, what does it have? Okay, we'll go for it instead of taking all that. Right, we have ID. Okay, for this movie. Okay, this is a movie. Suppose this is a movie. This movie should have one ID. Okay, that ID is one. Like this movie is having one ID. That ID is two. Like that, every movie is having one ID. Suppose you're placing an order. Suppose you're placing an order in the Amazon. You're getting the order ID or not. The same thing here also. So order ID will be changed on for every kind of product you are placing the order. That's it. Here also the same thing. So every movie having their own ID itself. Okay. Okay. These are the IDs. Okay. This ID, item ID is same to this item ID itself. Okay. So first data frame item ID is same to that second data frame item ID. Okay. Because these two are synced. So I got the data from the different source itself, and these two are in a sync itself. Now we need to match them together. Okay, we need to match them together. Together. Right. So how do we match, guys? Yes, simple df dot match of df is my data frame and move it as it is my data frame. On which item you want to match? On these are the two data frames, guys. This is my second data frame and this is my first data frame. I want to match these two data frames on the common feature called as item ID. Okay. If I run this at itself, yes, now it has been clubbed together. Now it has been clubbed together. Okay, my voice is breaking. Maybe for you it is breaking. Okay, because my internet is quite stable over there. Right. Is my voice is breaking, guys? The other guys, please reply. It is fine. Okay. Right. Right. So all of you are telling that my voice is clear. Yeah. Yeah. Please check on your internet, guys. Those guys are telling that they are breaking. Right. Clear. 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 Right. So now we have set a proper data frame. Like now we have set with the proper data frame. It's like user IDs and their item ID and their ratings given for that title of the movies which they were watched out. So every user will not watch the all the movies. So no, suppose you're using the Netflix. Did you watch all the movies which are loaded in the Netflix? No. So some user, suppose the user ID of one will watch few movies and user ID of two will watch some other few movies. So the watched movies will be rated out. The other non-watched movies will not be rated out because they didn't watch that movies. So every user ID will not watch all the movies and the other user ID which is common to the other user ID will watch the vice versa itself. That's their choice. Okay, now we are going to see that all that factors like some EDA process, we are going to see that. Okay. Now we are going to follow a particular procedure of EDA. Okay. Because EDA, it's quite common to do for artificial intelligence and ML algorithms itself. That we are doing now. So we need to check few parameters like now I need to check let's create some ratings. Okay, I'll just copy paste that sentence which I want to tell that. And now I just want to create ratings data frame with the average rating and the number of ratings on that scale. Because so I need to know that which movie has got good ratings and that rating should be given out by huge number of people. Okay, that's what my main scope of theme is that because suppose some other movie X movie is there, only two people have been watched out and the two people have been given the 5-star rating. Suppose the two people are given the 5-star rating. So if I am the user watching the good rated movies which are watched by 500 users and given the 4-star rating, would you recommend that the movie which is watched by only two people with 5-star rating? No. Why? Because I am the watching the movies with good star rated and good number of people given that ratings. So So I need to recommend a movie. So I need to get the recommended movie such that it should be very high rated movie, and that too, the more number of people should watch that movie itself. That's what the motto of that. Okay, that's what we are going to see that. Okay, that's what this statement is all about. Let's create a ratings data frame and with the average rating and number. How do we create that? We have a concept in the where is that? We have a concept in pandas called as df dot sure guys. So now we'll get back to see that df dot read, sorry, df dot group. Okay, df dot group. Now we are grouping down that title and ratings on that scale. Okay, like for that title of movie. Okay, for the title of movie, how much is that ratings should be done on that scale? Okay, for that average rating given to that, right? Let's check that. Okay, as you can see that there are various movie given out that ratings in the mean. Okay, these are the few movies given out the ratings. So now you got the ratings column onto that scale. Okay, I need to sort that itself because it's not in the sorting order. I need to sort that. Sort to underscore values. In which order I'm sorting that to ascending equal to false. Okay. Then in that scale, I don't want all the list. I want just only 10 numbers on the list itself. So I'll run that. Yeah. I can see that the average movies given out or these movies, as you can see that these are the top movies which are 5-star ratings. Okay, this is the top movies for 5-star ratings. But now the question arises that. So these are the 5-star rated movies. Okay, good. And you can tell that these are the 5-star rated movies on that. But who have been watched? How many of the count have been watched that movies? Let's check the count of that because okay, this is the movie watched by only one person and given the 5-star rating. Then it could be a 5-star rated movie only. It would not be a 1-star rated movie. Okay. Now I want to know that how many people have been watched this movie itself. Okay, I want to see that how many people have been watched that movie. Just I just copy that code itself in the previous code where it was there. Instead of mean, I'll check for that count itself. Let's check the count because I need to know that how many. Sorry, I need to know that how many persons is given the rating for that. Okay. That's what we are going to see now. Okay, just want the count on that, not an average or the mean. If I run that, right, as you can see that these are the 5-star rated, the top 5-star rated movies on that scale. Okay. Okay, these are the top 5-star rated with an average of 5-star rated. Whether that could be a person's watched by 10 or 100 or maybe 500. So this could be an order. But this will give you the number of people being watched the or given the ratings. What is this give you the count? This count will give you the number of people being given that count itself. Is that clear? Till now it is clear, guys. Yes. Okay. Okay, good. I need a responses from all of you guys. Right. I'll revise once. Okay. Right. Okay. What all you done? Right. Subham, I'll revise that. Just give me a minute. I'll revise that. Yeah, guys, give me a reply that if you are watching or using that, seeing that. All right. I don't understand when ascending is taken, some of the values got eliminated. Why, sir? Yeah, because the values are being now ascending equal to false. Means I need a top to low. All the elements are not eliminated. I am taking only the top 10. Taking only the top 10, guys. After that, I have put the top 10. That's what you need to see over there. Okay. Kindly refresh. What to refresh? Okay. I need to refresh this. Okay. Right. So we have loaded the data set itself, guys. First, initially one data set contains the user ID as well as item ID and the rating and the timestamp is been available over there. So this is one data set, and the next data set is all about that items. Okay, for one movie, one item is been generated. That is the next data frame. So for this both data frame, ID is common over there. For the both data frames, ID is common over there. Can we give descending equal to true? No, 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 no. Ascending is the only factor. If ascending is false, you can give the false. If ascending equal to true, you are just giving the true. True or false. That is, if you give one, it is will be vice versa itself. Right. Okay. Where we are? Right. Now we are going to match that to what kind of that data frames itself by the common factor called as title item ID. So we have merged that. Now it's time to see that I need to recommend a movie which is good star rated movies. Okay, suppose a person is watching a good star rated movie with good number of ratings given by the candidates. So for that candidates, we need to recommend a movie which is good star rated and number of candidates being watched out. To get that all that factors and just grouping down with the title and the movie ratings itself and the title and movie ratings and their average ratings itself. Average ratings. Suppose 10 persons has watched this movie. Okay. 10 persons are given that 5-star rating. Okay. Then the average will be 5 only. So like that, if one person is watched this Shadow and Light movie, he is given 5-star rated. Then the average is also 5. So like that, the movies are been coming out in the order. So we don't know that how many numbers of the persons or how many number of persons have been watched or how many number of users have been watched this movie. So it is ascending equal to false means use true or false. True or false is nothing but it's on or off. That's it. Ascending is should be on. The order should be in ascending order. Sorry, descending order. The order should be in a descending. Then we write ascending equal to false. If your order should be in ascending order, then you write ascending equal to true. It's nothing but true is been on, false is off. That's it. Can you tell me one more time? So, yeah. Ascending equal to false means, guys, ascending is the option where we are taking from highest to the lowest, general, ascending equal to. We are telling that ascending should be false. Means if ascending equal to false means the opposite is what? Descending is true. Okay, true means it is on. Descending should be on. Ascending should be off. That's what. Now it is clear. Right. What next thing is that I want to check the count of the number of persons giving the rating of that, guys. I just want to see the count itself. So I seen the count over there. So after seeing the count, we just check out. Now it's time to check that. We have seen the count over there, but I want to set that number of columns given that ratings over there, guys. I want to see that number of persons has given rating for that movies exactly on that scale. So next what we do, we have set that ratings columns to that main ratings itself. So I just want to add the columns which are given out over there. So what you do, we just put the same code and add a new column called ratings on that column itself. What is that new columns called? Ratings column. So we just put down ratings. We just copy the same code over there, which we are going to use, like pd.group by and the count given out there. This code will be copying down as is. Okay, but I just want to add the two columns which need to be available beside over there. Now what I do, I take before that to run this code over there. Okay, which is ratings given out over there. Okay, this is the code for I want to set the same code for the ratings. This is what mean we are doing and taken down as a ratings. So now I want to add. Now we got that ratings given out with the title. Okay, I don't want that kind of. So for this ratings, how many persons has given the ratings? How many number of persons has given the rating? That's what. With the ratings column, I need to add that column also. Which column, guys? Like number of ratings. Number of ratings. Clear? I just want to add that columns to that equal to pd dot equal to that should be in the data frame itself. pd dot data frame and put this same code which I copied over there the previously. I think it is clear for that. Okay, now if I run that, okay, check for the ratings dot head over there. Check for ratings dot head. I am just seeing nothing is there, guys. I'm just seeing out the ratings to how many persons is given. That's what my motto is that. Okay, how many ratings is given for that number of persons for this movie. So this is a movie called Till There Was You. Okay, this movie is rated by 2.3. But how many persons? Only 9% has given the ratings. So I just want to see that how many persons has given that rating, that kind of things itself. Okay, I'm not going with any data exploration things, guys. Okay, now we will go back into directly into the process. So there you can do some explore the data by some kind of visualization tools, guys. Now I'm not going to do all that things. Okay. Next thing is that we are going to do the pivot tables over the guys. What is that? Pivot tables. Now we are going to do the pivot tables. To get the pivot tables, what does these pivot tables will do? Pivot tables is used for, okay, I'm just creating the pivot tables. Later on, you'll get to know that why we are creating these pivot tables. So I want to see that how many number of movies are being rated. Like everyone will not watch all the movies. Someone will watch some movie and some other user will watch some other movies. Like, so I want to see that which users IDs are given that ratings over there. Okay, I'm just keeping index to the user ID. Next columns. I just want to keep the columns equal to. Now what I want to keep the columns to the title. I want to keep the columns as a title over there. Next comma, values. What could be your values? Values could be your ratings. So by these, with these factors, I want this data frame. What is that? Movie math data frame. Okay, let's run that code. So data frame is not, so where do we miss? All right, this is pivot underscore table. Sorry. Right. Let's check for that. Now what is we got, guys? Now we got all the users. Okay. Suppose if we check for user of 0. Okay, what does user 0 as how many movies is watched? Yes, would watched only one or two movies. Suppose we see that user 2 has watched this movie and this movie and this movie itself. Like that, every person will be watching few movies, not all the movies. These are the list of all the movies. These are the list of all the movies, and these are user IDs all. And their user IDs. Suppose I am the user. My user number is 4. I am the user of 4. I have watched few movies. Out of all this, I am watching the few movies, and their movies will be rated on like this out of 5. The other movies will be kept as none because they don't watch that movies. Now I want to do that recommendation over there, like which movies gets good rating over there. What we do, we just check that rating dot sort. Okay, we just want to go that sort method over there. So we do the sorting, which we have seen in the previously. Okay. Okay. The code is quite common. Okay, where I copy that code, paste it. Okay. Ratings underscore sort values of the number of ratings based on the number of ratings ascending equal to false. Okay, with this highest number of ratings, because the highest number of people's watched and their ratings, I want to check that. As you can see that Star Wars, as you can see that Star Wars is the scientific fiction movies, and this Liar and Liar is the comedy movie itself, because I only watched these two movies because I don't know all these other movies. I didn't watch that. So Toy Story I watched out. Okay. So I'm saying that Star Wars is a good movie because the number of persons rated out is very high. 584 is the highest count. And we got a highest rating also in that some scale. So I'm just putting out the order. Now, now, now let's choose that. Let's choose that movie called Star Wars. Suppose you are watching a movie of Star Wars. You are watching a movie of Star Wars, guys. Which is a journal of which journal it is? Scientific fiction movie. Like, okay. Now you're watching Star Wars. Okay, which is a scientific fiction movie. Okay. Right. Okay, which is a scientific fiction movie. So, which movie should we recommend to you? After watching this Star Wars, which movie should be recommended to you? That's what we are going to see now. So, now we'll see that Star Wars. Now we will go back and see that Star Wars underscore ratings. Okay. Star Wars. Okay. Of user ratings. I want to just see that how many users have given the rating over there. As you can see that, so number of people have given the ratings over there. Okay. Like 584 people have been rated. Okay. I just want to see that by this factor called as, which is that movie math of, what is the movie, guys? Star Wars. The Star Wars available. Star Wars. What is that name given out? Star Wars 1997. Space 1997. Okay. Now let's check that. Star Wars. User ratings dot it. Is that okay? Capital letters, I think so. Here I missed out. Hmm. Hmm. Right. Okay. So, just spaces are double over there. This is one space and this is two space. Okay. I just missed out the spaces. Okay. As you can see that user zero. Suppose I am a user of zero. I watched that movie and given the 5-star ratings. So you're the user of two. You watched the movie and given the 5-star rating. And you're the user of three, not watched the movie. So I am not being rated over there. So my rating is zero. Okay. Like that. Now I want to find that correlation itself. Okay. Between two series because the movie is watched by the Star Wars itself. I need to recommend another movie with the same similar ratings and the same kind of journal itself. So that's the reason I need to check for the similar of the Star Wars. What does I do? Similar to Star Wars. Star Wars. Similar to Star Wars. Equal to same. What is that? Movie math. Movie math dot. What is that syntax called as correlation with? Okay, correlation with which correlation, guys? With that Star War correlation. So no. Star War user rating correlation. I want to see that. Clear? I am just going to run that. Okay, that's it. Now the relation is been settled down. The correlation has been done now. So every time you call similar to Star Wars, it will find out the Star Wars related similarity of the movies itself. That's what that recommendation here now being started. Okay, it will find you that Star Wars correlation movies itself. Now we are end itself. Okay, now we are going to run a simple line of code again. I'm just copy and paste that code which is done previously. And now I'm just seeing that that's similar to Star Wars in the correlation and other values which are there should be dropped now. All the NANs are available, should be dropped and in place with the same code itself. Let's run that. So now you can see that correlation has been done. Okay, as you can see that these movies correlated to these and these movies correlated to this. But now I need to sort that correlation itself. What I do, guys, if I need to sort that correlation, a simple thing is that what is this name? Because these are the lowest rated, lowest watched movies. As you can see that previously we have seen that. Where is that the same data? Yeah, these are the lowest rated movies or not? So the rating is okay, good with a correlation of negative also fine. But I need to set for that correlation, guys. I need to set for that correlation now. So what does we do now? We are going to see that ascending equal to false because I want only the top rated correlation of the movies over there. So I just want to see the correlation of the top only, which are there. I just want to find out only that kind of correlation top movies. Just what you do, that the same code I copy over there and put the ascending equal to false. That's it. So because ascending equal to false means I want to see that top rated on that scale movies. Okay. Here you will see that the title and the correlation because all the correlations are one. All the movies are correlated to one, which are scientific fiction movies. But how many users are given the ratings? Because only 10% has given the rating. That movies are also included. But now I don't want that. I need to set one figure. Like I want tell that 100 persons need to be rated. Okay, 100 persons need to be rated. At least 100 members should be watched that movie, and that movie should be good rated and should be a scientific fiction movie, and that could be similar to my Star Wars. Should recommend to me. Okay, I think the point is clear, guys. Is that clear? I should get the movies which should be watched by so many people. For example, which should be watched by 100 member of people, and the rating should be good, and that should be very correlated to my Star Wars movies. That should be that kind of movie should be recommended to me after watching the Star Wars. Is it clear? So that what we need to do now? We got all the correlation now. So we need to set that number of ratings should be greater than 100. What does we need to set that? Now let's fix the filtering out with a greater than 100 of number of reviews. It is clear, guys. No reply from your end. Guys, I just want a replay from you. Come on, need replace. Right. Now we are checking for the movies which are greater than 100 itself. It should be greater than 100, the number of ratings. So a simple line of code which we are following on that scale. Okay. Now the code is similar, but number of ratings should be. So what we are doing, guys? We are writing the same code what previously we are written. We are just copy pasting that code. Just a second. Okay, we are copy pasting that code. And where I need to change is that we are going to change here in the inside part over there after correlation over there where we are going to change after the correlation Star Wars. Okay, in that correlation of Star Wars. Okay, now what to set that inside number of ratings? What is that number of ratings? Number of ratings should be how much is that, guys? Greater than 100. So no, should be greater than 100. Right. Now it is greater than 100 itself. Now everything is fine. We are not disturbing the code itself. We'll run that code. Okay. Something error we got. Number of ratings key error. Number of ratings we didn't take that. Okay. Just a second. We missed out number of ratings column over there. We are taking number of rating, guys. Yeah, number of ratings is available. Let's check for that. Okay. Mm, okay, let me run once that cell itself. In the previously we got number of ratings, guys. Let's see that. Only we got correlation. Okay, let's see that why we missed out correlation with it. So stored values. Okay. Let me run once over there, guys. Let me run this cell once. Okay, fine. Okay. Correlation of Star Wars dot start values. Right. Let me run this cell once. Okay. Here you can see that, guys, we have missed out the correlation number over there. Right. Okay. Now let me run this once. Is there any spelling mistake over there which we are taking down? Star Wars. Okay. Is that a number of ratings? Right, right. We got it. One second, guys. Share the screen. Right. Okay. We are missed out with an ascending equal to false over there. Right. So now you can see that we have seen that number of correlations over there, guys, with the number of ratings given out. Okay, now as you can see that the ratings are very low. The ratings are very low for this kind of movies. In the Star Wars, the rating is the number of persons rated is 584, which is huge number, and we got good ratings. So we are checked out for 100 ratings. So we are now going for 100 number of ratings given out by the candidates, and we checked that, and we got that as correlation as one, because the Star Wars, after Star Wars, which movie should be recommended to that? What is the next movie, guys? Empire Starbucks, which is 0.74% is the correlation. Because after this movie, what movie is the correlation? When you talk about it is 74%, but the number of ratings given by that persons are 368. But the correlation of this movie is very high when compared with the other movies, which is 507 ratings given by the 507 rating persons. But the rating is little low because the candidates given the rating is very low. So that's the reason it is 0.67% of the rating of the correlation with the Star Wars movie. Like that, the first movie after watching the Star Wars could be your Empire Star Bags. Okay. After that, we have another movie recommended to the Return of the JD itself. Like after that movie, this is the other movie been recommended to that. So after watching the Star Wars, we will recommend a movie called as Empire Strikes Back. Okay, after watching this is the sequence of order because this is the correlation being maintained for that Star Wars movies itself. This is the similar way we need to do for the products also. Suppose you want to recommend one product like Star Wars, we are choosing one product. After, if the person is buying this product, which product should be recommended to that product, product itself for that users will be taken care by this the same procedure itself. The same procedure you need to follow the code. First, we need to find out that First, we need to find out the correlation with that movie itself. Suppose, or the product. Suppose you are taking one product of iPhone 5. So now you need to replace this Star Wars with your iPhone 5. What is a correlation? So what is a correlation? It will check in the backend. It will check in the backend with the degree of correlation, all that degree of freedom, all that. Next is the correlation has been done. So next it will give you that. Again, you need to check for the ratings. How much is the rating? You need to check for the rating ascending equal to false. And number of persons is your choice. How many number of persons is given that ratings? I am taking is 100. So that depends upon your check, your choice. You can take a 10 or 15 or anything. If you run that algorithm itself, it will show you that the first one is your choice, iPhone 14 or some other. Next, which iPhone should be recommended to you after placing that order itself. That's it. That is all about your recommendation engine, guys. So now we are going to start other process called as time series analysis. Okay, or time series forecasting. Okay, I just want to stop this screen itself. Just a second. I'll open another collab. Yeah. Sharing that screen to you. Yeah. Clicking on the collab. Okay, this is called as time series forecasting itself, guys. Okay, this is called as time series forecasting. So all of you are able to see the screen, I think so. Yes, guys. Right. Now we are loading the data set. Our data set is called as champion data set. Okay, this is price prediction of the champion. We are forecasting the price prediction of the champion data set itself. Okay, initially we are loading this data set. Okay, this is Perrin monthly champion data set itself. I'll copy the path. Initially the same thing which we are loading the libraries. Here now we need to import certain libraries. After that, I'll show you that what libraries need to be imported for this process. Okay. Now we are going to start a time series model over there. So what is this? Okay. First read that data frame over there. Let's go back to read that data frame. So what does this title? Will I put date for part 2 or time series? I'll put time series. Clear, guys? Right. Initially, we are just loading all the libraries over there. That's all that. Next, we need to read that data frame like pd dot history files. Like where is that path? Just copied over the path. If I see that df dot add, right, guys, what does it show? Okay, I'll just rename that like sales over there. How to do that rename over there, guys? So I'll just put that. I want column names. Which column names you want, you can put over there. Like tf dot columns equal to which columns I want, month, and I want this as a sales. So now it has been converted to month and sales like that names, as you can see that. Right, month and sales. Now what is that, sir? We are going to see that. Let's see the tail also. Tail. So we have how much year has been starting out, guys? It is starting from 1964 January 1st to 1972 I think August September. So we have sales values up to there. We have a sales values up to there. Now I need to forecast the next year sales. How could be my next year sales? Okay, how could be my next year sales? We are doing that forecasting technique itself. We are doing the forecasting techniques, but by the time series only. I'm not going to take any other parameters to predict all that things itself. By the time, based on the time factors of how many years? Like 64 to 72, 8 years. Based on the 8 years data, I'm going to forecast that sales itself. This is done by the time series analysis itself. So this is done by time series with certain algorithms. I'll show you that. Seconds. Now we have this kind of data, all that reading out. Okay. Now it's time to check like what parameters we need to change out that. Okay, we need to drop that few rows over there. So how many rows we can drop over there? Let's check that. Because 105 row is not there, anything is there. So we'll drop that rows over there, guys. what is our code df dot drop of 104 over 105. Let's drop that. Okay, next we will drop that 106 also. Let's drop that. Okay, now the dropping is done. If I check for df dot trail over there, oh, sorry, I'll put this comment because already I dropped that. That's the reason it's showing that. So all that elements has been dropped now. It's now the data is perfectly clean over there. Yes or no? Guys, are you able to follow me? Just give me a quick reply, guys. All the other guys. Following. Right. So now we are going to forecast that sales for the next year. But what is the next year, guys? The year could be any years. But now the year is 1972. Now we are going to forecast for 1973 as well as 1974 also. It could be possible. Say anything. So now I want to convert that into a date time format itself, guys. How do I convert? Because my let's check for the info. What is this itself? Like df dot info. Let's check that. So we have object type. Now I want to convert my month into a date time format type. What is that code? Just to type the code itself. Like to convert a month into a date type format over there. Okay, I'm just writing that code over there. Okay, TF of what is that month equal to ed dot underscore date time ed dot to underscore date time of which one I want. Of df of month. What is that? df of what is that month? Clear? Now we are converting that in a date time format. Is that M capitals? Right now it has been converted. Can we check once? Because it should be in a date time format, guys. Every time you see dates, all that factors need to be converted into date time format. Otherwise, it is coming like an object. Object is nothing but a categorical type. It should be. Otherwise, it show like a categorical type, guys. So now it is converted into a date time format. Yes, right. Okay. This month I should replace. Just a second. Okay. There are three columns because I changed that. Okay. Just we'll drop one column like so I'll drop a column like df what is the data frame called? df equal to df dot drop. I need to drop one column because it has been done repeatedly. So df dot drop. Okay. It's which column, guys? Any other? You can drop this one. One, two, comma, x is equal to 1. It's done. Let's step. Now let's check for that info. Yeah, now it is fine because I just done some spelling mistake. That's the reason I'm doing all that. Yes. Now it's time to do all the operations like let's plot it. First, let's plot it because what kind of plotting it shows, whether it's a seasonal trend or residual or cyclic, what kind of plot is that? Right. As you can see that what kind of plot is that, guys? It's a seasonal plot itself because as you can see that every interval of sales being done the same seasonal plot over there. Now we are going to test our stationary, test the model that our model is not stationary here. So we are now going to test the model to a stationary format, guys. So what to do that? The model to test that stationary or not. So let's see back that whether our model is stationary or not. So before checking the model is stationary or not, we need to import a library called stats model over there. That's what I told you that to work on with time series, we need to use a stack models. Let's look on that with the stack models. So now what is the command to test the stationarity? Because suppose you have a ball. Suppose you have a ball. Okay. If I pull an oscillation itself, you're standing in the middle. You're okay in the oscillation itself. You're standing in the middle. You're not able to catch that ball because it moves in and round over there. Because it is not stationary over there. Okay, it's not stationary. It is moving around down there. So in the same phenomena here also, our model which we are seeing out should become a stationary itself. We are converting our model. This model is now not stationary. I can see that in the plot. Now I need to convert that into a stationary to predict the analysis itself. Okay, to predict the analysis, we are putting the model into a stationarity itself. Okay. Now, to test that model, we need to import a library called or from stats models. Okay, from stats models. Okay. In the stack models, we have time series analysis. What is that called as TCA? What is that, guys? It called as TCA, which is time series analysis. In the time series analysis, we are importing stat tools. What is that called as stat tools? Okay, we are in that stat tools, we want to test the stationarity. We want one model called, import. We are importing a one technique called as add Fuller test. Okay, this is a test developed by a Dicky Fuller, a scientist called as. This is a scientist called as Dicky Fuller. So he developed that test. Okay, this test will show you that the model is stationarity or not. So that's the reason I am importing this. If I run that, okay, I run that model. I have imported this add Fuller. Now I need to test our results. I need to test our result whether it's a stationarity or not. What do? I do add Fuller. I do add Fuller in that df of sales. Clear? The sales, our sales need to be set for that. Our sales need to be set for that itself. Okay, our sales need to be set for that and doing that all that process. right? If I run that process, it's been set over there for the test underscore result. Now add fuller is been applied to that model. Next, so I'm just checking out that whether it is a stationarity or it is non-stationarity over there. It is stationarity or non-stationarity over there by an hypothesis testing. Okay, by an hypothesis testing. You know hypothesis where you have null hypothesis and alternate hypothesis. With that, we are going to check over there. So check it is a stationarity. Okay. With that model, we are going to check that it is stationary or not. Now, what we do, we just apply a function called like add fuller. We just apply a function called add fuller. Add fuller underscore test equal. Okay, this is my function name. I just want to check that function with the sales reports. Okay, sales report. And next, what we need to do, we just want the result. What is our result, guys? Result is add fuller of sales. I just copy this. Result is what? Add fuller of sales. Result is what? Result equal to add fuller of sales. Right. Result equal to add fuller of sales. Now what do we need to set down? Now we need to set for that labels also to print that. What kind of labels we want? We need to set for the labels called as ADF function. ADF is it add Dickey Fuller. We want add Dickey Fuller test on what is that number. Okay. And we also want p-value. P-value is a very much. P-value is a probability value. With that probability value, you are going to finalize that it is a stationarity or not. Okay, this is all about your statistics, guys. If you want, you can refer descriptive statistics over there in your concepts. And we are also going to see the lags itself. What is that? Lags. Comma. What is that? We are also going to see the number of observations itself. Like number of observations. Right. This is my labels. Now I need to run a loop like this. What is my loop? For value, comma label, value, comma label in zip. The value, comma label in zip. What is my result, guys? Result, comma labels. I'm just zipping on, guys. Result, comma labels. I'm just zipping on to that. So this is clear, I think so. The value and labels is just zipping down to result, comma labels on that scale. Right. Now what to print? Now what to print? We have a print called this, which I've been copied down in the text over there. I just paste over there. What to print over there. Right, this is what we need to print over there. What is that? If result equal to result of 1 is less than equal to 0.05 over there, we need to use this itself. We need to use this. Right, else it will show that it is a unit root and indicating that it is not stationarity. Now it's time to check for the stationarity or not. It's time to check for the stationarity or not. It's done. It's done, guys. Now we are checking that stationarity. Now what to do? Now add fuller test is applied to that and finding out that stationarity or not. Okay, guys, are you able to follow me? Now what we are doing? we are now checking for the stationarity. Our model is stationary or not. Guys, replay from that. Are you able to follow? So by this add Fuller test, we are checking for the stationarity itself. Add Fuller underscore test. Yeah, just I want a replay from you guys. All of you. Right. Just give me a quick replay. Okay, right. Right, all of you. Right, now I want to check for that whether which value of what is my p value could be. What is my p value could be now coming out. Let's run that. Right, we got 0.3639. Generally, what could be my value should be less than 0.05. Then what you should tell that you reject the null hypothesis, which is that it is stationary. Generally, I got that it is not stationary over there. Our model is not stationary, guys. Now I need to do my model stationary. So what to do? We need to do some differencing. We need to do some differencing itself. So what is this differencing? All that, sir, is that differencing is nothing but a seasonal difference. Generally, it is of 1 year difference or not. Yes or no? The model is 1 year difference or not. Like when you observe that from the year wise, you can see that 1964, 64, this is first month. This is second month, third month, like 1 year difference has been taken down. Like 1 year means 12 months of the values have been there. Okay. For first month sale is there, like second month sale is there, third month sale is there. Now we are taking a 1 year sale difference. We are taking a 1 year sale difference. Why you are taking all that is that we are taking that 1 year sale difference to set our model into a stationarity. Let's see that we are checking the 1 year difference of the model into a stationarity. What does we do then? This is a seasonal stationary because 1 year is a seasonal one. Because every year with the sales is going on. So that 1 year is a seasonal one. Seasonal and okay, seasonal first difference equal to df of what is that we need to put sales, df of sales here minus what is that difference we need to put, guys, of df of sales. Is that clear? Dot how much shift I want? I want a shift of 1 year. 1 year means how many months are there, guys? 12 months. 12 months shift I am doing that. Right. 12 months shift has been done now. If I check for df dot head over there, you can see that what is that difference I have done. Right? If I check for 15, then you'll get to know. Right? The first 12 months has been taken down as a difference, as a negative. I am shifting that first 12 months and from the next year, 1 year I am taking the difference because to set our model into a stationarity. Now our model is not stationary because to forecast our data, to set our model into stationarity because you'll get the fluctuations in the values on the sales. So you're not able to predict or forecast the exact values. So that's the reason we are setting our model into a stationarity. Right? Okay, that's what. To set our model into a stationary, we are shifting down into a seasonal difference. Like what is a seasonal? We have 1 year of the difference. So that difference we are setting down. This is what 24752 2541, which is of minus 197. And this difference, like 30312 2475 is 276. Like that, this difference has been calculated over there. So now to set that difference, and again we see the Dickey-Fuller test over there for the difference value. How do you see that? Dickey-Fuller underscore test. For what test you are going to see, guys? For DF of which one? Seasonal first difference. Because I converted seasonal first difference over there, dot drop none. Of if any null values are there, you are going to drop that. That's it. Okay. Now if I run that, right now we got the p value and our model is stationary or not? Yes, guys, our model is stationary or not? Guys, are you able to follow me? All of you, all the guys are able to follow me? Just a quick replay. All of you. Right. Okay. Now our model is been done to less than 0.05. Now our model is stationarity. Now our model is stationarity, guys. Right. I want other replays, guys. Only if you are replying. Guys, please respond. Now, if I plot this stationarity itself, so what could be our graph? Did we import all the libraries? No, I think so. Import matplot, leave over there. Let's see that how this plotting has been done, guys. Dot plot. Yeah. Now our graph looks little stationarity over there. Because as the peaks goes on, but when you draw a line on the zero scale itself, it becomes a stationarity line over there. Okay, now our graph or the model looks now stationary. Now it's time to see for that stationarities on the graph, like with the plotting of autocorrelation factors, we can see. So to run our model itself, now we are going to run the model, guys. So we have two methods called as, one method is called as arima. The next method called as sarima. Guys, we have two methods called, one method called as arima, the next method called as sarim. So what are these two methods? So these are the two methods used for forecasting the data of time series. The first one, when you divide the space itself like this. Okay. Okay. If you divide the space like this. Right. So this is average method. Okay. This is called as average method, or generally called as sorry. All right. Auto-regressive methods. Okay, this is called as auto-regressive method. Okay, what is a AR? It's an auto-regressive method, guys. AR is an auto-regressive method. Clear? AR is nothing but auto-regressive method represented with the symbol of represented with a symbol called as Q. Sorry. Right. Right, represented with a symbol called as P over there. Okay, next one I is nothing but integration or difference. What does it call as? Integration or difference. Now we have taken the difference. How much is the difference we have taken? 1 year difference. Then your D value could be 1. Okay, which is D is 1. Next one is MA. MA is moving average. What is that, guys? Moving average. Then that symbol is represented by Q itself. Q. Okay, this is all about your ARIMA. 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 AR is auto regressive, which is value represented with P. And I is integrated. Okay. I is integrated with D and moving average is Q. And next model called as SARIMA, which is seasonal ARIMA, which is called as seasonal ARIMA. So these are the two models, guys. What is that? First one is ARIMA. Next one is SARIMA over there. ARIMA and SARIMA over there. These are the two models. Sir, when to use these models? It's that. When to use these models? So if your model is getting stationarity in the first process, if your model is getting the stationarity of applying the first Dickey Fuller test, then you need to use the ARIMA over there. Then you need to use the ARIMA over there, ARIMA model. Suppose your model is not getting stationary and you are applying the seasonality difference over there. I have applied the seasonality difference only or not? Yes or no? Yes. When you are applying that seasonality difference, you are applying that seasonal ARIMA over there. You are applying a seasonal ARIMA. So now I will apply that seasonal ARIMA to our model. Just a second. So what is that code? I'll copy that code over there. Applying that seasonal ARIMA. And where to get this? Where to get this PDQ values? So where can we get these PDQ values? Now we are going to get that PDQ values by importing that stats model dot graphics of dot TSA. TSA means time series analysis plots. We are getting the plots of ACF and plots of TSES. We are now importing that. Next, to run that plots over there, to run that plots and get that code over there. So we need to get that code from the graphics, like plotting that PSEF and ACF. So we are just plotting for ACF, autocorrelation factor ACF. So we are plotting that autocorrelation ACF over there. So we are plotting that autocorrelation ACF. Before that, I need to import. Right. We have imported that SM model or not? I think so. Okay. All right. Now we are going to run this model anyway. Okay. We got, what is that error called as system is not defined. Okay. Let's copy over their code. Right. Right. We need to import the stats model over there. Okay. As SM. Import that stats model as SM over there. Initially, I missed out. Okay, now let's run this code. Okay, I think it work. So to get that graphics, null force difference. What is that spelling? Yes. Now we got ACF and PACF factors like because this partial autocorrelation is used to find out the values of Q itself, and this autocorrelation function is used to find out the values of P. So generally after shut off means after the first value where you see that drastic decrease in that. So that number you need to take. The first this line is 0. The next line is 1. So this line should be taken down into the factor where you see that sudden shutdown. So here also you see the sudden shutdown in the value of 1. So we are taking that PDQ values as 1 over there. We're taking that PDQ values as 1 over there, and we are going to run that functions of seasonal ARIMA model, guys. We are running the functions for that seasonal ARIMA model, like putting that model calculations over there. So we are running the model of seasonal ARIMA. So this was that we are model dot SM means stats model dot time series analysis of state space. And now because this is a seasonal difference, I told you that if you are going with the seasonal difference, if there is any seasonal difference, you need to move out with the seasonal ARIMA. If there is no difference, the model is direct to stationarity, you need to apply that auto ARIMA model itself. So now our model is seasonal difference. So what I am doing now, my model. So what is my p-value? P-value for the autocorrelation is 1, comma, Q, a difference value D equal to 1 and Q is also equal to 1. Okay, because I told you that from the graph, what you are seeing in the above. Next, these are the PDQ values, and this 12 is the how many months of the difference. We have shifted how many values? 12 values or not? In the previous class, you can see that we have shifted 12. Yes or no? Shift is 12. 12 means 12 months we have shifted. We have shifted 12 months, then our model got stationary. That's what our PDQ comma S. S is the shift. Generally, I run that model, result dot model dot fit over there. Okay, what is that model package? I didn't mention over there. Okay, right. I need to set further forecast of my model, guys. I just missed out. Yeah. Yeah, I need to run that model of ARIMA. Okay, I need to import this ARIMA model libraries itself. I didn't import that. So I need to import this ARIMA model telling that from stats model dot time series analysis ARIMA model import ARIMA over there. Right. Okay. What is the error coming out? Right. Sales. Okay, now the model is been done, fitted, completely fitted to that seasonal ARIMA model, which is Sarimax model. Right? Seasonal ARIMA model. Now we need to forecast the data. That's what our final thing is that. What is that? We need to forecast the data itself. How do you do that forecasting? Just simply, how many values you want to forecast, guys? how many values you want to forecast. So generally, as you can see that what is our last, guys, what is our last cell of that? If I take d of dot tail, what is our d of dot tail, guys? How much is the last number d of dot tail of that index? Is 104. So I'll start with 103 over there, simply. Okay. I'll start with 104. 104 to next to 24 months I need to forecast. So now if I run the trial model of that, okay, I'll run the trial model of forecast. So sales comma. Right. You can see that forecast goes on as usually with that sales itself. Yes or no? My forecast is going with the as usually with the sales. Now I want to forecast for the next years, not this one. Next years I want to do the forecast. For the next year, I want to do the forecast over there, guys. So now I need to add that series offset of data, because next year's index should be added to the previous years of index. Like this is my last year, DF of index of that, because that is 104 need to be added, and I need to forecast for that next years of that data. I need to forecast for the next years of the data. Okay, data offset. Okay. Which are data offset is not supported over there. We have missed out any other names. Okay. Right. We didn't miss out. We have missed out with the value over there. Okay, that data set should be offset by keeping the name first. Okay. This is my screen. Okay. That data offset is being taken down over there. Okay. Now we got these data predictions for that 24 rows of columns over there. So now we have a range of 24 columns over there. Okay, now I need to forecast for that 24 months of the forecast. Then these next 24 months of the forecast is to be done before starting that. So I do the concatenation of that. Next, what is my last index is 104. From that 104 to 120 of that forecast need to be done. If I run that cell itself, I can see that forecasting is been done for the next 1970. I got the data from 1973 of the middle of the month called as September. So I am going to forecast for the next 24 months itself, guys. I can see that forecasting has been done. This is the way of the forecasting. Okay. There's a way of doing that forecasting technique, guys, with the time series itself. We don't have any kind of data other than time. With the based on the time, we are going to forecast. This is applied for the stock markets, guys. This is applied for the stock markets. As we see that for if you want to take the stocks of Yahoo, okay. So we take the Yahoo stock market of the data for the last 10 years, and we are going to forecast what could be the next year itself. Suppose the 2024 Yahoo stock price you want to forecast. The last 10 years of the data, time only, on the time and the closing price or the opening price of the each and individual day. Only take that two columns and you forecast that with the same procedure, nothing is the difference. Then you will get to know that how this forecasting has been done exactly for the next of couple of years. So what kind of couple of years you can go through that, what years you want to forecast on that scale. Right. Yeah, any doubts or any queries, guys, with that recommendation engine and this time series? That recommendation engine and the time series, any queries, you can ask me in the chat itself, guys. Right? Any queries? All of you have understood the concept, guys. Just ping me yes. Just ping me yes, guys. All of you. I want to reply from all of you guys because there is huge number of people. Sir, we can use any data set. Yeah, you can use any data set itself. Okay, what does correlation with function do? Yeah, correlation with function will find out the correlation between one variable to the other variable, because if I want to, in the previous case of recommendation, it is being correlated. It checks for that. For that, how much is the rating and how many number of people have given that ratings. That too, like that kind of similarities is been matching. Is there any values matching with the same similarities? It will find out that and put down that in one list. Okay, it put down that in one list itself. So all the other guys just keep on replying that. If you are understood that, yes, please ping me. All the guys. Right. Okay, fine. Right, guys, tomorrow we will see that neural networks. We'll see that CNN. We'll work with resonant 50 on that tomorrow class. Okay. Right. Right, Amar.
Yes.
Yeah. I can leave for today. Can time series can give output Boolean values? No, guys. It will only used for forecasting the data. It doesn't give any kind of value. Will give you the graph of the data itself, and you can get the values on the forecast itself. That you can get that, but Boolean values like true or false will not be available over there. Right? Yeah. Right, Amal. Can I leave? Yes, Amar. Are you there?
So guys, I already shared the attendance link in the chat box. I hope all of you mark your attendance. Or if you want me to share it again, if yes, let me know in the chat box. Oh, lots of participants are asking me for the attendance link. Yes, I'm sharing it once again. Please mark your attendance. And don't forget to share your feedback as well. Guys, tomorrow will be the last day of this training program. So please be there as advisory inform. Will look on NLP parts. And as of now, if you have any query or question for me, please. Sonali, what you want to repeat or you want to share it? Okay, attendance, yes, guys, I shared that. Anything, guys? Questions? Sir, can you please provide any material for this session? Not any. Samantha, we already shared the day 1 to day 3 material over the LMS. Guys, I think lots of participants are there. You want to see how to access the material? Lots of participants asking me were not able to get the material. Attendance link not come. Hey, how it's not come? Okay, guys, please share it again, sir. Share Srinidhi. Srinidhi. Yes, yes, I just shared. So I hope you received now. Okay, I think lots of you are able to access the LMS, so not required to take Kitty again. So who is facing the difficulty? Let me check the Sri Durga. So Sri Durga, do one thing, drop an email to edl@tesla.com. Tomorrow, any of our team member will connect with you and they will help you regarding to the LMS. Okay. So don't need to worry, you will get all the material. Day 1 to day 4 materials are day 1 to day 3 materials are already there, and by tomorrow afternoon you will find the day 4 material as well with the IPYNB file. Okay, guys, for your future reference, I'm sharing the email ID with all. Unnecessarily don't send email ID, don't send any mail like good morning sir, good night sir. If you're facing difficulty, definitely you can drop us an email. We'll be there for your support. Thank you for sending the materials. Reader, thank you so much. I hope you are able to access via LMS. So 27th 11 2023. This day I am attended the class, but I not fill the Google form. Shreya, why you not fill the Google form? What is the issue? Me too. Yeah, but guys, what is the issue? Why you're not able to fill the form? I would like to know about the problem. Then I will give you the solution. Or else then I will, sir, how I reach the material. So yes, material is there or the LMS. So few of the participants are asking me, can I leave? Yes, definitely. We're done with the day. I did not get the link. It's not the answer because me, myself, I hope all of you know me, myself, Amar, shared the attendance link multiple times in the chat box. If other participants are there, they can help me in this. So, Amar, I did not got the link. We shared the link. If you are asking for today's link, definitely I'm sharing that once again in the chat box. Don't worry about the, if you're missing 1 day attendance, it's not going to affect on your certificate. But if you are missing 1 day session recording or 1 day live session, definitely it will affect, because whatever we are covering in this 5 days now, it's important for your future perspective. I hope you are enjoying the session and you are gaining a very insights from these, right? Am I right, Sonali? Yes, informative. Where will get the material? So Shreyash, I think you are one of the interactive participant. I'm seeing your name from the day one, and I already informed that as well. Sorry guys, my voice is not good. So you will get the material over the LMS. And same scenario, if you're facing difficulty to access the material, then you can reach out to the EDL team over the edl@xlar.com. I know there are few professors, then doctors, then HODs, teachers are there. I'm saying, guys, to all of you, please don't feel bad for that. Thank you, Sridhar. You're welcome. So, guys, can we wind up for the day? With your permission, today I will wind up. Okay. Sorry. Yes, no, anything. 150 participants are there. I just need 8 replays at least. 1, 2, 3. I need a 5 more replays. Okay, yes, yes. Yeah, now I got the 20% replies. Thank you so much, dear participants, and see you tomorrow. Bye bye.